Hi guys, welcome to Learn Electronics Repair. A friend gave me a couple of Powerline adapters. In fact, actually, he gave me 3 of them. And he said, you can have these, Rich, for free. And they might be useful to you, if you can fix them. So, nice friends give me broken Powerline adapters. And I think they just want to see if I can actually repair them or not. But anyway, this is what I have for free. So this one says nothing, no lights. This one says nothing, no lights. And this one says it can connect to the device, so obviously it does power up, but no internet, so it can't connect to the internet. I'm assuming he means that it's not connecting to like the sending device for the internet. Chinese and can't alter, so I think he also means to say that the menu is in Chinese and he can't change it, okay? So we effectively have one that powers up but doesn't receive the internet across the mains wiring, and 2 that don't power up. These seem like the ones that are more likely to be fixable. I mean, maybe that one too. So let's have a look inside these and let's see what we have. I've never looked at a Powerline adapter before, I will say. I don't know if you guys ever have, so maybe this is going to be an interesting journey. Okay, let's start. I'm mostly into one of the dead ones, so I've got the front cover off it. They were basically held by 2 screws and then a spudger to release the clips, but they were quite tricky to do. And this top PCB looks like it comes out. And it looks like there's a power supply board underneath there. That looks like a switch mode down there. So let's see how easy this comes out of here. Well, fairly easily. Yeah, so that's out. These 2 come apart by the looks of it. And we have it. So this looks to me just like a switch mode power supply. Little buck regulator there as well. Little transformer. Could be wrong, but it looks sort of like that. Oh, and we have some bulge capacitors. These 2, they're domed, yeah. I wonder if this is as simple as that. I'm just looking, this is a opto isolator. Yeah, this looks like the output side to me. Or this could actually be the input side, thinking about it. Yeah, you've got power, an inductor, capacitor. This is, yeah, filter choke. That's what I can see here. Some sort of chip here. The fact it's got 1 pin missing there tells me this is the high voltage. This is the transformer winding. Yeah, you can see it. So this will be the pulse width modulator and MOSFET in one that drives this. It's actually damaged. See this line across here? No, it's more like a scratch actually. This is your transformer there. So this is the secondary side here of the transformer. Yeah, you can see the secondary windings. Then there's a little buck regulator, so I'm pretty much sure we have another power supply here. So this switch mode will produce 1 output voltage on this diode into these 2 capacitors and an inductor. Yeah, that makes sense. And then this then generates another voltage, probably a low voltage from here, a volt or so maybe. This will be a higher voltage, I would assume. 16 volt capacitors, maybe it's a 12 volt supply. You can't really say exactly. All you can say is it's less than 16, yeah. And these capacitors have definitely gone. These are the output capacitors. So look at another one, see if it's the same. Okay, so here's the second one. I'm expecting to find the same problem. This is the other dead one, basically. And this one, well, one of the capacitors is gone. The other one looks okay, but it's probably bad as well. So it looks like we have 2 of them with bad capacitors here, at least. And here is the kind of working one. I've put a little blue dot on just so I don't mix this up. Let's see, is this looking okay in the capacitor department? Yeah, they all Are they okay on this one? Let's have a look. Well, yes, this one has a different type of capacitor fitted, and these actually look okay. So even without the good one to compare with, I think we can say the problem with two of them is just capacitors. So these two are bulged. In this case, only one is bulged, but I'm going to pull them both out and check this one as well. It looks visibly okay, but I'd be interested to see if it actually is okay, considering this one is gone. I've also noticed on these two boards that the ones at the back are black and gold, and these are blue and gold, but they're the same value. I can't imagine that's anything to do with the rating of the ESR. Let's have a look when we take them out the boards. Well, here are our capacitors. So these two, 105 centigrade, SAMWI, okay, and these two, also SAMWI 105, SRS 828, SRS 828. So apart from having different coloured sleeves on, I mean, they look basically to be the same capacitors. Let's check them. This is the one that looks good, so let's try this one first. That reads low ESR. Yeah, there we go, 0.02 basically, a bit lower. This one is one of the bad ones, so this is the other bluish coloured one, slightly bulged. And that's really high, yeah, 81, I mean, that's really bad. This one. Well, that actually reads open, yeah. The ESR is so high on that one, this actually reads open. Interesting to see how these read on a capacitance meter, don't you think? And this one. Also reads open. Those are as bad as I've ever seen. Let's just try with a capacitance meter out of interest. Here is our good one, or it looks good. Is it reading 470? Yeah, fairly close. I mean, these things are not very close tolerance, maybe 20 to 50%, so I would say that's probably okay. Let's look at this one. This is one of the ones that reads open. And it basically has no capacitance. Okay, we'll turn down the range. Well, it has some, 4. Let's go down to the next range, to 20, okay? Not even 1. So this is definitely a bad capacitor. This one I'm sure is exactly the same. 1 point something. And this is the one that read about 70 on the ESR. 70 ohms. This one actually has some capacitance, okay? So although the ESR is 70, it does read some capacitance, but not a lot, 120, okay? I'll replace all 4 of these anyway, so these are new ones. Low ESR, Chong X, 470 microfarad, 16 volt. I get these from AliExpress. I buy a whole bag of 100 or so at a time, usually bags of 100. These work great, I've used them a lot, and they don't come back. I don't seem to get any problems, so I'll use these. We'll put them in, and then let's see whether this actually solves the problem. We'll just give these a clean. Somebody commented that I clean the PCB with isopropyl alcohol, which is what this is, this solvent. And then I clean off the alcohol and what's left with kitchen roll. And they said that was very good and that I was the only one they see who does that. So my comment to that is I can't see why you wouldn't do that. I mean, it makes sense that after you've softened up the flux with isopropyl, you're not then going to leave the solution, which is a mixture of flux and iso, on the PCB. Yeah, to dry out, it just spreads itself. I mean, I don't see why you wouldn't use kitchen roll to dry them out afterwards, but somebody commented on it, so yeah. Comments below. Yeah. I think it's necessary. If you don't, let us all know why you shouldn't do that. Yeah. Okay. Before we just try these, I'm interested to see how this thing actually works. So this basically is a power supply. The mains is coming in here, live and neutral, and this is generating the power for the adapter to work. And this is the Ethernet board. So you have your Ethernet sockets to the router at one end, to the device you want to communicate with at the other end, connected via the mains wiring. And this also has the Wi-Fi. We can see the antenna wires here. So this, I would think, is the Wi-Fi module. But somehow this has to communicate with the other device via the mains wiring. So it must be sending Ethernet signals, data, to and from the other device via the mains, and it must do that effectively via this power supply. So how does it work? Well, I've never looked at one of these before. I've never Googled this to see how these things work, but I'm just looking at this now. We obviously have the high voltage side, the main side, and we have the low voltage side, okay? And somehow, one way or another, the communication of the Ethernet data goes across one side to the other. Now, that's an opto-isolator. I would imagine, but I'm only imagining, that is used to regulate the output voltage. But it seems a little bit strange because it's like this is marked as pin 1. You'd think this would be the LED side of it. Yeah, there's a dot there for pin 1, and normally that side is the LED, the sending side of the opto. So you would think that was going the wrong way to control the pulse width modulator to set the output voltage of the power supply, okay? So we have that. I mean, we can find a data sheet for this. Give it a bit of light. Part number is PC817, but then we also have the BT839, yeah, so one of those numbers. We'll have a quick look in a minute at that one. What's this thing? This is the funny looking thing, okay? And this doesn't appear to have any markings on it. Let me try, see if I can read the markings on the other ones. There might be something on there. Just hard to read. Oh yeah, there is something on there. Let me see if I can read one of them. With the microscope, I can actually see this does clearly have a marking on it. So this is SC1162K2, and then another number 7S947A. So let's see what we can find out about this chip, and let's see which way round the opto-isolator is connected on our board. Well, here we have the PC817. Do we have a proper data sheet here? Looks like it. Pinout. Okay, so 1, 2 is the LED side of it. That's how I thought it should be. Okay, and the other chip. Can we find anything else about this one? Well, I'm not sure I can find the exact data sheet for that. I can find similar things, but they don't have the K2 suffix on. And it appears to be a slightly different device, because this is a 24-pin device. It's a programmable synchronous DC to DC converter with a low dropout regulator. So it's effectively 2 voltage regulators in one. One is a switching one, like a buck converter, and the other one is a linear regulator, basically. That would not explain how this thing actually works, if this is in some way transmitting the data back onto the mains, but not having an exact data sheet. it may be difficult for us to work that one out. This is an interesting device really, because as I was just discussing, how does it work? How does it send the data from the mains wiring to the Ethernet? This opto isolator is wired the way I thought it was. So the LED side of it is on the high voltage circuit, and then the transistor, which is effectively being controlled by the LED, is on the low voltage. And if we look on this here, we can see we have a couple of high value resistors in series, so 330k, another 330k, so 660k. We have a diode there, and that is effectively wired to the AC side of the bridge rectifier. So this is the AC coming in. So conceivably, that could be sending some data across from there to there. Oh, hold on a minute. I figured this out. I know what this is doing actually. So we do have the LED here on the high voltage side. This is the photo transistor. This is the opto isolate. Okay. And this is where the mains comes in, live and neutral. So if we go from here, this will either go to the resistors or the diode. Let's see. Doesn't go to there. Oh, yes, it does go to there. So we have continuity to there. And then from this end of this diode, we'll have to here. Yep. And this is a diode. And if we look at it, positive to negative, it conducts this way. Okay. And if you look at the diode in the opto isolator, that also conducts in that direction. Okay. So what we have is this. We have AC coming in. This is your 50 or 60 hertz mains, depending where you live in the world. And basically, the diode is connected across here. So this goes to your bridge rectifier, AC, AC, plus minus, DC, and into your power supply, the big smoothing capacitors. Okay, across here, and so on. So this is 220 volts AC here, and this is the DC, maybe about 320 volts. Did something just walk across my page? Oh, maybe a bit of dust. Okay, we do get a wildlife here in Gran Canaria, if that's what it was. Back to this, so this is 320 volts DC. Now our diode is wired across here, our opto isolator, and I think it's this way round, but it would work the same the other way round. We have the diode that we can see on the PCB. Then we have the opto isolator with the LED. Okay. And then we have two high value resistors. 330k, 330k. And this comes back to here. Okay, that's how it's connected. So on here we have AC. Because this is a diode, of that matter, this is also a diode, the current will only flow in one direction. So when this end is positive in relation to this end, that's the positive half cycle, current will flow through here, through our LED, through the resistors, and lighting up the LED by doing so, okay? And here we have the photo transistor, which is on the low voltage side of the opto isolator. Okay? So when the light shines on the photo transistor, it switches on. So as soon as the half cycle starts, the positive one, this will light up and this will switch on. So coming in, you have positive half cycle, and out here, this is on the low voltage side of the circuit, and this will have a resistor here to some supply, like 12 volts, okay? When the switch is on, the transistor switches on. So the voltage on the collector, assuming this is connected to ground, which it will be, you would think, the voltage here on the collector will go to 0. Okay, transistor's on, it's 0. And it'll stay 0 while that LED is lit. As the half cycle comes back down to 0, this will go off. Once this goes off, It's not shining on the transistor anymore. The transistor switches off, so the voltage here goes up to 12 volts, for example, or whatever voltage this is. So we get that. And this will stay off now all the way through the negative half cycle, because it's reverse biased. So we come back to the positive half cycle again, okay? At this point, this will light up and this will switch back on again. And you'll get another, like so. So what you'll get here is a square wave at 50 hertz or 60 hertz, depending on your main frequency. Yeah? That's what you actually have. So what this is doing, this signal is going into the logic board, the Ethernet board. And every time the square wave either goes off or on, in other words, the falling edge or the rising edge of the square wave, every time you have a falling edge and a rising edge, this circuit knows that we've crossed the 0 point. Okay? It knows we've crossed 0. And it also knows the polarity of the half cycle of the mains, i.e. was it falling, in which case I've just passed 0 heading down, or was it going up, in which points I've just passed 0 heading up. And the logic circuitry obviously needs that for some reason, some sort of synchronization. It, for whatever reason, needs to know when the mains passes 0 and possibly which direction it's passing in. Okay, so that's what that does, guys. Looking at this chip again, okay, I couldn't find an exact data sheet, but this is on the high voltage side of the circuitry. This is switching. The switch mode transformer, it can't receive data the other way, even if this could somehow send it back out. And this also is connected, if you like, to the main smoothing capacitors. So no data could get past there anyway. The only path for data really is through the opto-isolator, but that's not a bidirectional device. So guys, sometimes I can look at things and I can figure out how they work, but in this case, I can't. Unless I'm just missing something fundamental. That's most likely the case, yeah. So, there we go. Really, I'd like somebody to explain how this works. I thought, okay, I've asked you guys. And I thought, well, just go and Google for it, Rich. Yeah, just do the obvious thing. So I went and Googled how do these work. And I found a couple of hits on YouTube, good place to look at. And we have a couple of useful links, you think. Yeah, this one, Tech Quickie. So I had a look at the video. So you're going to teach me how it works. And you know what, guys? I don't think he knows how it works. Ah, yeah. I mean, he's made a video.
Click the subscribe button, then enable notifications with the bell icon so you won't miss any future videos.
I mean,
as awesomely convenient as Wi-Fi is.
I mean, he's made a video on how does it work, but, well, he just says it works because it works,
Powerline adapters have internal logic that allows them to catch the signal.
So, it turns out that he doesn't know how they work. Luke.
Like sound pitch or the frequency of a Wi-Fi band, AC power has its own waveform with a frequency of 50 or 60 hertz, depending on where you live.
Of course.
So Powerline Ethernet works by simply sending signals through your wiring at very different frequencies.
Okay, that makes sense.
With modern implementations of the technology between 2 and 86 megahertz.
But how does it do it? Yeah.
Kind of like how DSL internet provides high-speed internet access over the same wiring as your landline phone by using a different frequency. You can learn more about that up here. And like conventional Ethernet, Powerline adapters have internal logic that allows them to catch the signal. Kind of
does it look like he knows how it works?
Like your smartphone or laptop can catch a Wi-Fi signal that spreads out in all directions.
Okay.
Well, that's great and convenient and all, Linus.
He's shaking his head, this guy is, guys. He's shaking his head. He doesn't know how they work. And I've had a look at one or two others, and nobody seems to know how they work. We've looked at the PCB. We know what's on there. How does it work, guys? Oh, my God. I think I've just seen a YT tech presenter have a brain meltdown there. Yeah. But he's telling you how it works. Okay, so let's have a look. This is our power supply. The mains comes in. Okay, bridge rectifier, large capacitors, controller chip, switch mode power supply, zero crossing detection, yeah, direction and timing, yeah, secondary output, low voltage output. So there's no way the Powerline adapter can send a signal back into here. It can't send the Ethernet information back through this because, well, first of all, there's lots of smoothing capacitors. Secondary, there's no path in that direction through the optical isolator, even if it wasn't being used for what it's being used for, yeah? And there's no way you have the transformer here, this chip is on the high voltage side. It just can't send the information that way, not that I can see, which is why I Googled it. But now we know that, well, we know what we knew. It sends information onto the mains wiring. Yeah, nice one. So, how does it work? Well, it must send the information another way. I mean, is this a radio transmitter that somehow receives on the other side? What are all these, like, dots here? Is this an antenna? Is this another antenna? No, I think these are just wires connecting one side of the board to the other, effectively for heat sinking, yeah, and for current path on both sides. It's just heat sinking and large current path. But we do have this connector. Now this connector is on the main side. This is the high voltage side, and if we have a look at it, next to it, we can see some more high value resistors. This is 1 mega ohms and 1 mega ohms, so 2 meg. And I'm sure these are connected to here. In fact, we can see they are. So from one end of this connector here, then through the resistors, that's 1 meg. The other end will go to this side of the mains, live or neutral. Okay, let's get a good connection on it there. And then the other live or neutral, whichever it is, doesn't really matter, will go to the other side of the connector. So we're going, let's call it live, we're going live via 2 meg to this connector, and the other side of the connector is going to neutral. And if we look on this board, we have a connector here, and we have, look here, T5, okay? This is a transformer. It goes from the connector to one winding on the transformer there. And it's quite a large transformer physically in this direction. This will be giving high voltage isolation. Okay, that's why it's wide. It has one winding over here and another winding over there, separated by an air gap, if you like, or just the ferrite bead. So this is giving electrical isolation and, to some matter, physical isolation from the mains. So on this side, this controller will be sending the RF signal modulated with the Ethernet data into here, isolated by the transformer, down into here, via these high value resistors and into the mains. And that's how it's actually receiving and transmitting data, onto the mains without my brain overloading. And that's because we know how it works now. So let's see if these will power up now. I'm going to put the current limiter in the light bulb just in case. So I have the current limiter on. This is the one that supposedly did power up anyway. So we have that one in there. Let's see what it does. Well, the power light's on. Yeah, we can see it. Went up red there. It's gone out. The light bulb didn't come on, so it's drawing extremely little power. Now let's look at this one. Just get the other little adapter thing for it. That one does work. Okay. Let's have a look. Well, that one doesn't power up. I'm not sure how good a connection this is making, actually. Try again, see if this one works now. Yes, red light's on. Okay. So, guys, what have we learned? Well, we've learned, if this is the first time you've watched one of my videos, or we've reinforced the fact, if you've watched many of them, that one of the most common components to fail are capacitors. And they fail in all sorts of ways and cause all sorts of problems. So, we've learned or reinforced that one. We've also learned how these things actually work now. Yeah. And as an aside, we've learned never to present a YouTube technical video on how something works if you haven't got a clue how it works. Yeah. So there we go, guys. Yeah, it was a bit of fun. You can have a dig at me for having a dig at somebody else, but I like at least to say, if I'm going to explain how it works, I'll explain how it works. And if you guys come and tell me in the comments, Rich, you were wrong, I'll accept that. I'll come back and make another video and say, actually, well, such and such said it works this way, and he was right, yeah. And hold the hands up, yeah. So there we go, guys. Hope you enjoyed it. The other one with the thing with the menu and Chinese and whatever, you know, unless somebody gives me a good reason, I'm not too fussed with that one. I was given these things for free anyway, and 2 working ones for nout. That's an old Stoke-on-Trent saying. 2 working ones for nout. I'll put it into English. 2 working ones for nothing. That's got to be a good deal. Okay, hope you enjoyed that. I'm sure I'll be hearing from you, as I mentioned, and I'll see you all soon on another Learning Electronics Repair video. Ciao for now, guys.